Welcome all. I'm glad to see such healthy enrollment in this class. I think that it serves a really very useful purpose for the IMPS program and for others who are interested in the subject matter. This paper is kind of a case study in what's called biopolitics or biology in politics, in which people study the relationship between biology in its many forms and politics. Some people focus on the implications of biology for public policy. Others look at the implications of biology for human political behavior. Biopolitics has gained some traction lately. If you're a political scientist and you read the American Political Science Review, Journal of Politics, other major journals, articles are now showing up when they were very rare once upon a time. Also, the Handbook of Political Science. Version 1 came out in 1996. This is a huge volume, like 1,200 pages long. There was not a single index item having anything to do with biology and politics. In the 2009 version, in the introduction, the editor wondered if evolutionary theory, biology, and politics might be the next big thing in political science, and there were numerous citations of literature in that volume. So there has been some greater appreciation and interest in this linkage. So this will be kind of a case study there. Terrorism is one of the main drivers of homeland security. In the all hazards approach, we consider both natural disasters and human-made disasters, and terrorism is one of the drivers of such policy. Understanding the underlying causes of terrorist activity is an important issue so that we can determine what tactics and strategies might be appropriate. At the same time, various political actors have to understand that biology can be, at the other end, a tool to be used by terrorists. Today I'm going to talk a little bit about a look at the biological agents and how we might address the threat, and also about some research which has examined the possible relationship of biology to terrorism, and my main focus would be suicide terrorism. Since I'm going to refer to evolutionary theory, this becomes a very interesting subject because evolutionary theory focuses on how behaviors and so on facilitate reproductive success. Think about this. A suicide terrorist who's a young male without children, he succeeds. There is no reproductive success. How could such a behavior emerge? It fundamentally violates major assumptions of evolutionary theory with its focus on reproductive success. So that will be one of the issues that I take a look at. Much of the literature is speculative, as you'll see, but it provides, I think, an interesting take beyond some of the more standard literature. First, for those of you not particularly conversant with evolutionary theory, what I'll do is just do a very simple overview so that we have some vocabulary in mind, so when I talk about suicide terrorism, you can circle back to this. Charles Darwin's version of evolutionary theory is essentially defined by two very simple propositions. There is variation among organisms within a species. Some people are tall, some are short, for example. Second, some of these variations provide survival advantage for those individuals who have them, and hence over time they would be selected for. Now, to be selected for means you're more likely to survive and reproduce. And if these variations have adaptive value or adaptations, then they will show up in later generations, theoretically making individuals better fit for their environments. Ernst Mayr, who was the dean of evolutionary theory, he was writing books in his mid-90s. I just find myself stunned by that. Evolution, thus, is merely contingent on certain processes articulated by Darwin: variation and selection. Natural selection is itself the process by which individuals whose characteristics don't fit an environment so well tend to die off before reproducing, and if their characteristics fit the environment pretty well, they're more likely to survive and reproduce. I'd mentioned the term adaptations before, and that's what we refer to characteristics that provide survival value. In that sense, those who are better adapted are more fit. There was once perspectives around, I was going to say turn of the century, but I'm talking about the 19th to the 20th century. People who thought that nature was red in tooth and claw, and the most fit animals were the ones who were the toughest and the best fighters. That is not what we mean by fitness. We're talking here about adaptation and reproductive success. One term that has generated a lot of interest in the study of evolutionary theory is something called inclusive fitness. The idea of fitness here, again, is adaptation. Some characteristics are going to make you more likely to survive and reproduce. Inclusive fitness says that there are two primary routes to this. And there's debate among evolutionary theorists on this, by the way. But the first is individual reproductive success. It's where an organism reproduces successfully, okay? That, again, keep in mind, variation and then retention of characteristics makes you more likely to successfully reproduce. However, there is another route by which our fitness can increase, and that is if our relatives successfully reproduce. I mean, the standard example is we would share half of our genes with our offspring. So if you die and 3 offspring live, you're ahead of the game. You have contributed to your reproductive fitness through inclusive fitness, the success of your relatives. Any behavior or characteristic that increases inclusive fitness is a candidate to be selected for. What does this have to do with suicide terrorism? Humans are strange creatures. We can create our own reality. We can create values which sometimes will have us doing things that don't seem to make any sense in terms of natural selection. Humans find it easy to internalize values and beliefs and subordinate behavior to those as a part of human nature. Now, this makes a certain sense because natural selection, if we have widespread agreement on basic values in a society, that creates a more stable society. In a more stable society, there's more likely to be widespread reproductive success. So characteristics that contribute to societal stability also create an environment where reproductive success is more likely. Greater stability, more reproductive success, behaviors that would lead to stability then could well be selected for. And many people in biology and politics have examined possible candidates for these values. In fact, I've written a book on democracy. You look at democracy and you say, humans tend to be creatures who engage in dominance behavior, with some being alphas, some being omegas. How could democracy come into being? And the argument is indoctrinability. If democratic values become widespread, we will be less likely to be involved in dominance competition. Religious values are other candidates for indoctrinability, and this is very common. Sometimes you see behavior that you really don't understand. Masada, Jonestown, religious values led essentially to mass suicide. That's not really consistent with reproductive success when you have large numbers of people. In warfare sometimes we see soldiers engaged in suicide attacks. You think of Pickett's charge at Gettysburg. He lost a huge number of troops. Why in God's name did they march into a situation where they knew a lot of them were going to die? Or federal forces at Fredericksburg. Many soldiers would write little notes with their name on it so that after their death they could be identified. When you've got soldiers doing that, they don't think they're going to make it, okay? And religious values are sometimes associated with people doing things that seem to go against reproductive success. But if those religious values are widespread and contribute to stability within society, then being indoctrinable supports reproductive success. Biology and terrorism. I'm going to give a couple different studies which approach suicide terrorism from the perspective of inclusive fitness. Okay? Kruglanski's is one of those, and you'll see some commonalities among these, but I think it's useful to give several examples here. Kruglanski and his crew argue that the need for physical survival is associated with a quest for personal meaning and significance. There's a desire to contribute to your society, small or large, and as humans many zillions of years ago were in smaller groups, that would be wanting to contribute to the small group's success. The authors quote Crenshaw, a well-known scholar of terrorism, and she said, "Sacrifice for the cause contrasts with an otherwise insignificant," that little 2 letters missing changes the meaning, "insignificant or disappointing life." So somehow being involved in the defense of a group, being willing to sacrifice for it, makes you feel more significant. Suicide terrorists themselves often are told, come to believe that they will become a martyr, a hero, and will be revered by group members. That makes you feel significant, going back to Crenshaw's quotation. The evolutionary factor here is death as a hero can serve to enhance reproductive success of relatives to the extent that they become more esteemed by their association with a hero. There are some cases when families of suicide terrorists get material benefits, which will be useful. As a result of becoming more esteemed and more attractive as possible mates, this could enhance reproductive success of relatives and thus be explainable by inclusive fitness theory. Some jihadist ideology mentions immortality and the wedding of many partners for male suicide terrorists, and there are comparable rewards for female suicide terrorists. So in a way, if you buy into the ideology, you're going to be unbelievably reproductively fit after your death because you're immortal and you will have many, many partners. So that's the argument by Kruglanski et al. Thayer and Hudson, something similar. They have a somewhat different starting point, that humans evolved in resource-poor environments. In order to distribute the goods of life that you need, dominance hierarchies developed. This helped to distribute scarce resources, would maintain as a result group survival, reduce within-group conflict because people would know their place within that hierarchy, and promote feelings of loyalty and belonging. One of the things that Thayer and Hudson say is if you look at many studies, and there's debate in the literature, by the way, on terrorism and suicide terrorism, but this is their starting point. Terrorists in Islamic groups tend to be young, single, often without children, and lower status in groups' dominance structures. Suicide terrorism and its act of sacrifice may be a vehicle to higher status, enhancing again the standing of relatives, which may facilitate more successful reproduction by those relatives. Again, consistent with inclusive fitness, where if you sacrifice yourself and you die, but your relatives are going to be more reproductively successful, then that makes sense in evolutionary terms. In addition, they also echo Kruglanski et al. By saying that the prospect of mating with many women in the afterlife may be another aspect of reproductive success driving terrorist actions. If you accept the beliefs, then you will be very reproductively successful after suicide action. Scott Atran has another argument. I won't go into this because after a while there is similarity here, where he argues that religious beliefs weren't directly the subject of natural selection. What happened is that humans many years ago would interpret certain things. For example, wind going through leaves and the sound there, and they would come to see that as the voice of some kind of ethereal figure. And over time, this could become like the voice of a god. And so that people would be then willing, many people, to accept religious values and so on. Certainly not everyone. One route from religion among Islamic males is through coming to define fellow group members as brothers, the development of fictitious kin, fictive kin. You come to look at them as brothers. If you commit suicide in a terrorist act, and somehow you feel that that supports your brothers, in a way you've been captured by the ideology and you kind of go against reproductive fitness, but in the sense by dying you're contributing to the success of people you see as brothers. Also points out that suicide terrorists are likely to be single, young, and religious. It shouldn't be not religious. Another typographical error. I caught many of these before coming in. So religious beliefs are a part of the motivation. Al-Qarda has a somewhat more exotic argument, and it focuses more on the human brain. He argues that brains of adolescents go through rapid change during their adolescence, leading to increased risk-taking, more novelty-seeking, non-kin peer relationships, romantic attachments. In the brain, the dopamine system, it's a neurotransmitter, changes, and it's associated with the pleasure system of adolescents and adults, and to motivation. So what we have is people who are more motivated to take risks, to seek out new experiences, and the motivation is kind of reinforced by a sense of pleasure for these things. These can be associated, in Al-Qarda's mind, with increased power of religion through music and other rituals, so that people may attend more to religious impulses. And in certain societies, religious leaders may use this as a way of trying to indoctrinate them into values that would support suicide terrorism. It's very common for proto-terrorists to be influenced by radicals in religious groups. And then keep in mind they have high levels of motivation, increased risk-seeking, greater links with non-kin individuals, and as a result, they can end up being seduced, if you will, into suicide terrorism. So through evolutionary theory and through the study of brain science, we might be able to see one part of the development of suicide terrorism. These are relatively abstract arguments, but again, they suggest the possibility that among the many other factors, religion, being kind of the lower ends of society and disadvantaged, are all part of a picture here of suicide terrorism. Next, I'll talk a little bit about agents of bioterrorism, some of the bacteria, viruses, other things, as these can be used as weapons. Take a little look at some of the most virulent of these, how prepared we are if these can be weaponized and used widely. Note that, in fact, biological agents have been used. Countries have developed biological weapons. And then talk a little bit about how governments can address that. That's going to be very brief, but at any rate, this will take another look at the relation of biology to terrorism through bioterrorist agents. First off, there are a number of means of delivering biological weapons. Through the air, aerosolization, through animals, through food and water contamination, and through person-to-person passage of the agent. And different kinds of agents have different characteristics, different ways of being disseminated or dispersed. Let's take a look at some of these agents. Category A agents are the ones that are most dangerous, more easily produced and disseminated, and deadly. Take a look at some of these diseases. Smallpox. It's nice to know that there is no smallpox in the wild, naturally occurring. Anthrax, pneumonic plague. Bubonic plague is not as weaponizable. Botulism, and so on. Hemorrhagic fevers. Those are category A and the ones that can be most dangerous. Category B. Some of these we're familiar with, some not so familiar. And then category C is emerging threats. We're not yet sure how effective they would be as bioterrorist agents. But there is that category as well. And this gives a sense of how effective these might be. The little pluses there, the more the pluses, the worse it is. And then the last column is special preparedness. How well prepared are we if these agents are released and begin gaining traction? Smallpox, well, it's only got one plus because there isn't any of it in the natural state. If there were, it would be a primary possibility as a weapon. It can be deadly. Right now, the production and dissemination, there's only one plus because there's nothing in the wild among us, if you will, in test tubes in a tiny number of laboratories. People to people, it's god-awful. 3 is the highest level. So if you got 3 of those pluses, it means it is deadly in transmission from person to person. But special preparedness, we're in pretty good shape. And what do we mean by that? They're a stockpile of therapeutic medicines to address it. There are public health surveillance and education efforts. And we have laboratories capable of identifying it quickly, which is important because if you don't know what it is, you can't respond with appropriate medicines. So that is smallpox. It's not a very likely agent at this point in time. But when you hear of accidents in laboratories with such agents, it makes you a little bit nervous. Anthrax, that is one of the most likely of the agents. It's deadly. It's a disease that can become widespread. The production and dissemination is easy. It's easy to produce. It's easy to disseminate. There are a number of different routes that can happen. It does not transmit people to people, and we are well prepared for it. And you can go down each one of those. There's no sense in talking about every one. You'll have access to this chart if it's of any interest to you on an Angel site, I believe, after the event is completed. Same thing with the B agents. You can see with the B agents, we're not quite as prepared. There's less people-to-people transmission. They aren't as deadly as a group as the A toxins, and they are not as vicious in creating the disease in the first place. So that gives you a sense of the reality among these various agents.
Hey Steve, I have a question.
Sure.
If you go back one slide, please.
Sure.
Just out of curiosity, it's tough enough for an organized enemy, but a lone wolf to use a biological attack. Are any of these agents something that could be common enough that a lone wolf person could get it and be a suicide?
Well, as I recall, we had a lone wolf once who sent letters with anthrax to a lot of people. It's easy to get it. Relatively easy. I mean, it's not like you go into a drugstore and buy it. But it is relatively accessible, which is one of the reasons that people are nervous about anthrax. And it can be disseminated in a number of ways.
What about the cholera?
I'm not so sure about that one. That's not as easily disseminated. Let's go down here.
Just because it's person to person, if you wanted to be a terror suicide. person. And we have no special preparation for.
Yeah, the B group we are less prepared for because those are looked at as less effective weapons. That doesn't mean they couldn't become weapons because some of those are pretty deadly when you look at death rates from them and so on. One of the reasons that it's important is that we've actually had nation states develop bioweapons and we have terrorist groups trying to use it. The Soviet Union once had a nice stockpile of anthrax. Some of it got loose, over 60 people died. Okay, so it's weaponizable. Iraq, they had stocks of anthrax, botulism, and aflatoxin. And then there have been small groups who have actually released salmonella to try to make people ill, and sarin. The attacks failed 3 different times in Japan, I believe, with the sarin. Just a couple case studies of some of the group A's. Some of you are probably familiar, others might not be, but it's, I think, useful to get a little bit more detailed look at some of these agents. Anthrax. This would be one of the biological agents most likely to be used. That's the judgment of the Centers for Disease Control and others. And I'm using CDC documents here to talk a little bit about these because they're quite credible. Its spores are easily found in nature, can be produced in a lab, and can last for a long time in the environment. Some of these toxins don't survive very long in the environment, and that makes them less deadly. Anthrax has more lasting power here. They could be put into powder, sprays, food, and water. They're so small, the spores, you might not be able to see, smell, or taste them. It's also been used as a weapon before, so we know it's weaponizable. In fact, the CDC says it's been used as a weapon for over a century in various cases. So this is a well-known agent. It's dangerous. It poses a severe threat in the CDC's mind to society. So that is anthrax, which has a long history as a possible agent. Botulism. This is something that comes from food. There are a number of bacteria that could be used to infect the food supply. Botulism is one of the more likely. Again, it's in category A, which means it's one of the deadliest. It's also relatively easy to deploy. It's considered to be one of the most potent and lethal toxins known. This is something that kind of struck me. 1 nanogram per kilogram is deadly to an individual. A nanogram is teeny. It's a point with a whole lot of zeros. This is another one that is, to me, telling. 1 gram could potentially kill 1 million people, according to scientists. So this is pretty deadly. If somehow you could introduce it into food supplies, it could cause problems. However, it becomes inactive pretty quickly when exposed to air. It's unstable even in liquid formulations. So it's not as bad as anthrax, which can survive. The spores can survive. And then finally, plague. Pneumonic, not bubonic. People would become infected 1 to 6 days after exposure to the bacterium. If given medicine quickly, the odds of survival are good. If you're not treated quickly, after 6 to 7 days, it's quite deadly. These days, pneumonic plague is relatively rare. There are more outbreaks of bubonic than pneumonic, but if it begins to spread, it would be quite virulent.
With ricin, is that figuring in as like something terrorists would use?
Yeah, that is looked at as a possibility, and again, it's been deployed already, not successfully, so it shows that it might not be as efficacious in delivery as something like anthrax. Using information from the CDC and other government sources, I mean, this sounds pretty scary because a lone wolf can disseminate anthrax or other agents. You don't need anything fancy for some of these toxins to deliver. So CDC and other people have talked about there should be multiple layers of defense against these. One is at the individual level. A few years back, I gave a presentation on avian flu when it looked like it might break out and start infecting humans and so on. One of the first things they said is create an individual level family plan. Have an emergency supply kit with food, liquids, and so on, so you can hole up, so to speak, and other necessities like that. Develop a family emergency plan. What if you're separated, kids in school and so on? How might you address that? Up-to-date immunizations, and then high-efficiency particulate air filters in return furnace ducts. They would screen out many agents so it could provide internal support. Emergency management services, there are articles on the role of emergency rooms and emergency physicians. You need adequate supplies of medicine that can be delivered quickly. In many cases, we have, for example, with anthrax, ample supplies for local outbreaks, and upon learning that it's anthrax, it can be delivered in a relatively short period of time. But again, quick supply of the medicine, ease of access to those supplies is important. Advanced planning. One of the things that was interesting is listening to an exercise. This is a number of years ago. I just thought of it a few minutes ago. Before Hurricane Katrina, officials from the federal and state government actually had done like a war game if a hurricane hit New Orleans. But there was nothing concrete that came after that. And they also, as I recall, local officials weren't involved. This is a long time ago, so my memory isn't so good. But even though there was like an advanced look at what would happen in New Orleans, there was nothing that was really developed, so you had close to chaos as a result. Cooperation among state, national, local governments. One of the things that's interesting, in Pennsylvania we have 9 regional anti-terrorism task forces designed to protect, but also if some kind of terrorist action occurs, including use of biological agents, they would be able to try to respond to the damage, help remediate from the damage, and so on. So there are a variety of approaches one can take after the fact, but trying to prevent, obviously, would be preferable so you don't have to deal with the after effects. So I've tried to use a couple different examples here, how biology might provide a part of the explanation for suicide terrorism, and also some of the agents that suicide terrorists or others who aren't bent on suicide might be able to deploy.